So I want to talk about the vertex, and this can be very confusing as to why we would learn something like this and what is the motivation of changing so many different things just to understand a single point. So I want to call your attention to an function that we have used many times, and this is just a quadratic function. We have x squared, where a, b, and c are just some real numbers, but we have just a quadratic function here. Now, we are going to implement some changes so we can write this same function in this way, okay? Now, this is going to be called the vertex form of our quadratic function, okay? Now, why would you do this, and what does this mean? So, to explain why we would do this, I want to call your attention to something we've already learned, and maybe it can be through the analogy, it can be better understood. So if I look at something like f of x equals mx plus b, this is just a line, right? Y equals mx plus b. Well, this is very useful to us. We use this all the time. So, you know, I can't think of how many times this semester we've used y equals mx plus b. Why would this be so useful? Because we can immediately tell what the slope is, and we can immediately tell what the y-intercept is. And with a line, since they're so simple, generally this is the only information we need to fully understand that, okay? However, this is not the standard form of a line. The standard form of a line is ax plus by plus c equals 0. This is the standard equation for a line, and this is useful if you're trying to define what a line is, but it is not very useful when you're actually trying to use or understand those lines. The slope-intercept form is much better when you're actually using them. That is completely analogous to this equation, which is going to be the vertex form. Now we have to understand what is a vertex, but this is analogous, where this is the general form right here, and we can understand things about it, but it's much more helpful if we're just given things in the right form so we can understand. So first, I want to just give an example so we can see how this would practically work, and then from that example we can understand why we would use this. So I just want to come up with a function that's easy to understand so we can see the benefits of this change. So I'm going to pick f of x equals x squared plus 4x plus 3, and this one's easy enough to understand. So first, let's look for the x-intercepts. Now the x-intercept implies that y equals 0. So if y equals 0, then we have x squared plus 4x plus 3 equals 0. And I can factor this for myself. So I can factor this as, this is a leading coefficient of 1, so I need to find the factors of 3, which add to 4. So I think x plus 1, x plus 3 would fit the bill. And this implies that x must equal negative 3 and negative 1. So these are the x-intercepts, right? Okay, now let's find the y-intercept. Okay, the y-intercept is very easily found, and this implies that x equals 0. If x equals 0, then y equals 0 squared plus 4 times 0 plus 3. It's an ugly looking 3, but that's a better one. So y equals 3. So this is happening at the point 0, 3. Okay, cool. So we can take a look at that function, and we can, or at least the graph, and we can try to understand what's going on. So let me draw a simple graph here. Here we go. we got y equals 3, x equals -3 and -1. I know that this function is crossing here, here, and here. And through inspection, I can find that this must be our function right here, okay? Now, something that's happening here with the parabola, remember this is a parabola, x squared. So it seems to be about here that this is the low point of that function, right? And I kind of wish I could find, if this was modeling a business or something, then you'd want to find where is this changing, right? You can find this in nature as well, but where is this function changing? So before it was going negative, 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 negative. All of a sudden it's going positive. Where did it change? Where is this point? Well, from this ugly looking graph that I drew, it looks like it's at -2, okay? And actually for this function it is, and it's easy enough to see where that is. But sometimes you don't automatically know where that is. And I want to remind you of something, and that is the solution to all of quadratic equations. So with something like f of x equals ax squared plus bx plus c, we found that all of the solutions have the form -b plus or minus root b squared minus 4ac over 2a. Okay. Now, actually, where that turning point is going to happen is right there. Okay. So when we studied our solutions, the x equals -b over 2a, this is where that function is going to do its changing. So we're going to use this. I want to save that. So we're going to use this to find that point, okay? So if I go back here and I'm looking at x squared plus 4x plus 3, I can say, well, the lowest point on this is going to be -b over 2a, which is -4 over 2 times 1, which is -4 over 2, which is -2. So this is the x-coordinate, which we already knew. We already knew that that was true. But this is the x. Now we can find the y by plugging it in. F of -2 equals -2 squared plus 4x plus 3. Whoops. We want to plug that in. -2 plus 3. So we get 4 minus 8 plus 3, -4, so -1. Okay? So there is the y. So then we found that this point must be -2, -1. This is called the vertex. Okay? The vertex. So it turns out that this will give you the x-coordinate, and then you can plug this in to the original function, plug it back in, and you can find the y-coordinate. However, if I give you something that's already in the form of this new formula here, you can immediately see what's going on. And so as it turns out, let me go to this screen again. If I give you something like f of x equals x plus 2 squared minus 1, if you understand that that is in the vertex form, then you can already pluck out what is the vertex. And the vertex is -2, -1. Since the formula has a negative in it, then we have to switch that sign right there. But this is automatically correct. So the function, or the formula, I should say, the vertex formula, has all of this baked in, okay? And it has a negative sign here, but this tells you the x-coordinate, and this tells you the y. So the vertex is HK. This will tell you the highest point or the lowest point. And you may ask yourself, what is the deal with this A? And the A tells you whether or not this is going to turn upward or downward. So if A is greater than 0, if it's positive, then it's going to be up as a cup, okay? It's going to have this shape, okay? If A is negative, it's going to be down as a frown, okay? So this is what we call upward and downward, all right? Now in our example, we had a 1 there, so our A is 1, and that's positive, so we knew it was upward. So this is just giving you an idea of why we might use this and how it's very helpful if it's written in this way. So I hope this helps. If you need any further instruction, please let me know. If you have any questions, please let me know.